Thank you all for making the terrible choice to attend my talk. Who here has never heard of me until today? Awesome. Good, good. You folks at least have no excuse. Everyone else, questionable. Okay, we begin with a relatively non-controversial, easy statement. Namely, that all of the various products that do this, that solve for your AWS bill or other cloud bills, kind of suck. And well, let me back up for a minute before I wind up going too far into that with a little bit of an introduction to who I am. I am a cloud economist, which is like a regular economist, only I dress way better. And what I do for a living is fundamentally go into companies with large-scale environments, and I make the AWS bill far less horrifying than it would be normally, which, yeah, kind of a low bar, but it happens. And this has led to some interesting insights over the past few years that we've been doing this at the Duckbill group. Starting with the fact that there's no SaaS product that tends to do a good job of this across the board. And there are a number of reasons behind it. And I'm not going to name the companies in question because first, some will get very offended that I called them out, and others will get very offended that I didn't mention them, and no one is happy. Welcome to technology. That if we want to have a single logo or slogan for our entire sector, no one is happy, is a pretty good fit. And they all recommend the same types of things, like buy some reserved instances for things you're about to turn off. Or, and this is always a popular one, turn off those idle instances that you've taken it upon yourself to label the DR site, because you won't need them until suddenly there's an issue. Let me give you a little bit of spoiler planning for when it comes to your DR strategizing and business continuity. If AWS or your cloud provider or data center, whatever it is you pick, loses an availability zone or a region, and your plan is to spin up stuff in another region, you're not the only person that has that idea. And when you test it, sure, you're the only person doing it at that particular time. But when everyone is doing it, control planes develop significant latencies. So if you need a DR site up and running, you probably want to go ahead and make sure it's there in advance. Does it cost more money? Sure, but so does insurance. And unlike buying fire insurance, you can pretty much guarantee your data center is going to burn down in one sense or another eventually. It's computers. It's what they do. They break. And strangely, an awful lot of them don't talk to you about things that you could discover with an API and would be incredibly valuable. But for some reason, I don't know, maybe they're keeping that as a hidden treasure just for themselves. We don't know. So even when you take about to the list of things these products can do, a lot of them aren't spectacular. Now, there have been a lot of talks for the last few days about culture, about empathy. And again, one of the things in our sector that is important is the idea of a blameless postmortem. We figure out systemic failures, we don't blame individuals. So I tried to figure out why this is and blamelessly determined that it's all venture capitalists' fault. I said I understand how blameless postmortems work. I didn't say I was any good at it. And the reason behind this is that they tend to have a pile of incentives that may or may not align in the larger industry. For example, everything they do has to be able to scale to world-spanning proportions. And if you've ever talked to someone who's done consulting or run a consultancy, you'll notice that hands-on professional services kind of don't work that way. People take time and energy, and you can't automate it away. So if you're trying to build something that you can do with little or no human interaction, it doesn't work past a certain point. So everything that they do that involves human touch, no, we're going to get out of that entirely. And of course, bonus points if they can call it Uber for something. In this case, cloud billing. Because Uber was the last good idea VCs funded that was moderately disruptive, and they're trying to find the next one. Before that, it was, oh, we're looking to find the next Yahoo. My apologies if any of you work at what remains of Yahoo. Moment of silence for that one. So I want to digress when we take a look at those incentives for a minute and disappoint you. If you didn't go to the workshop that's going on right now about deep dive BPF thing because you're worried about there being math there and there's no math here, I'm sorry. We're going to do some math. Assume, and we're going to start with AWS because that's the one, they're the market leader and it's easy to make fun of them. It's not punching down in quite the same way of some other cloud providers. If we assume that their revenues are $35 billion a year, which it roughly is, it's directionally correct anyway, enough for back-of-the-envelope calculations, and assume that you do what most of these companies try to do, which is charge about 3% of spend. You won't be able to do that, by the way, but it's at least nice to try for it. That means you theoretically have a total addressable market of a little over $1 billion. That is total addressable market, not technical account manager. It's not a really expensive support engineer, but it can be at times. So if you do the math on that and you realize that the entire market is just over $1 billion, that's kind of a shitty unicorn. The shittiest unicorn, however, is currently the working title for the WeWork movie in development. Again, I digress. But you're not going to be able to build an entirely massive environment out of something like this. You're not going to be able to hit that point of world-changing scale. But they're trying anyway. Now, there are some polite objections to this. For example, cloud spend only ever goes up, not down. You're right, it does. And there's more to just cloud than one provider. Very true. There are at least one other provider. I have it on good authority. Not that I've used them lately, but I'm told they're there. I mean, you have Azure, which is doing very well. You have GCP in there somewhere. Oracle has a cloud-ish. And IBM has a bunch of data centers type things that are currently infested with raccoons, but that's neither here nor there. But there are other options that aren't just AWS. The problem with approaching it from this perspective is that first, I don't care what people say, you don't need to have your different provider cloud spend in the same application because you're going to have different workloads at large companies running in different places. That's fine. That's called multi-cloud done sensibly. Multi-cloud done stupidly is we're going to take this application and be able to theoretically deploy it anywhere we choose to go. First, no one ever does. Secondly, when you build for that, you're passing up any of the higher level services. So instead of building the thing that your product actually does, you're messing around with how to reconcile a bunch of load balancers that all behave slightly differently. It's not a great look. It's not a great plan. It's certainly not something I would consider strategic. And no one cares about, oh, what are we spending on storage in GCP versus Azure? They care about what does that application cost versus this other application cost. Putting them together as an apples to oranges comparison doesn't really help anything. But it's easy to do with an API, so of course they're going to build it. And of course, all these cloud providers have terrible billing tools, but I'm sure that's always going to be the case because no one ever improves anything once it gets out there. If you start making fun of AWS in public, and I assure you, I am a world-leading expert on making fun of AWS in public. The first thing everyone complains about is the bill because it's a service everyone uses and no one understands. And wait a minute, aren't venture capitalists pushing back on this? The same folks who funded WeWork? Isn't that the company that they're building that shittiest unicorn movie around? Why am I taking business advice from people? It seems like very often venture capitalists, their story becomes, I won a lottery once and now I advise other people how they can win a lottery too. Awesome. That seems plausible. And all of this is completely beside the point, so you'll forgive the digression, because when you get down to brass tacks, none of these tools will fix the actual problem that you have with your AWS bill. And what are those problems? Let me tell you what your problems are. And out of respect for the code of conduct, I'm going to restrict this to the billing arena. It turns out that starting a conversation with, you know what your problem is, has a few ways it can go, none of them are good. But at the beginning, you very often will need to explain the bill to someone and why it has just done something monstrous to someone who's not actively touching anything that contributes to that bill directly. They often wear suits. The bill itself is incredibly complicated. In reasonably sized environments, you can see 10 gigabytes of effectively CSV. If you try and load one of those into Excel, first, your computer starts to sound like a battle tank, and then it smells like burning metal. And that means it's time for a better computer. It also turns out that not everyone who contributes to this bill is doing so in a responsible way. And this is not out of necessarily neglect, but also because people have other things they're focusing on. This is not, incidentally, just, I'm going to spin up the biggest one because biggest must be best and leave it running forever, although that is an example of it. But it's also people who, well-intentioned, waste incredible amounts of time on things that don't matter. Well, I just spent 6 weeks knocking $200 a month off of my developer environment. How much are we paying you? At some point, it winds up not adding value. You can always find ways to cut. At some point, it's time to stop doing that because you're not going to cost optimize your way to your next milestone. Once you have it with a reasonable bound, move on to the thing your company actually does. If it turns out that the core goal is to spend as little as possible to Amazon, just turn everything off. That is a surprisingly non-tenable business strategy for some of us. You also find out that engineering and finance tend to talk past one another in strange and interesting ways. And being in the room for those conversations is, at times, a little bit of a head trip. That's not to cast aspersions, it's just different people with different skill sets coming at it from different positions. Finance cares about things like allocation and prediction of what the bill is going to be. How much of that bill that I'm reading now, it says, oh, we spent this much on storage, this much on data transfer. Great. How much of that was for that service that just fell over and we had to spend a bunch of time repairing? Or the thing that runs our blog, what does that actually cost? Oh, you mean Kubernetes? That's the question that leads down a terrible series of architectural choices. But again, I digress. I'm not here to make fun of everyone, just some things. For example, you also know the bill has tax consequences. In the United States, there's an R&D tax credit where if you have things that are considered research and development, you can get tax credits for it. I am not a tax attorney or an attorney at all, or an accountant, or really anything you would recognize as a regulated professional, so don't ask me about this. But in a general sense, if you can clearly call out a portion of your bill as being eligible for tax credits, this has the potential to be millions of dollars to some companies. But you have to be able to defend that in a reasonable way when auditors show up. Yay, the auditors are here, says no one ever. It also turns out that as you're starting to build out services and products, and there's a varying charge that's associated with what it costs to deliver that, finance isn't happy. When they say, what is our cost to wind up servicing these customers, the response needs to be better than, You have to be definitive. And it still doesn't help because they want an actual number and you can only stumble or cough or mutter while saying a number so long before they have really interesting questions here. The point is that visibility and predictability matter. And we find this when we start seeing some of the same questions arising again and again. One of the more interesting ones that I didn't understand why the first time I saw it was, okay, at this point, every month we have a number of monthly active users. For a lot of SaaS companies, that is the metric that they define how they're doing by. And in this case, they say, great, so we're spending X dollars per monthly active user. Okay, how does that compare to the rest of the industry? And the reason that was strange is that every company is different. If I run, for example, my side project, Twitter for Pets, it's like regular Twitter, but 80 times less racist and terrible to women. Not a high bar. Some of those dogs are awful, but that's how bad real Twitter is. Okay, great. So each user interaction is not particularly expensive versus another company where each customer represents a large bank and they're doing massive amounts of computation and transaction storage. You're going to see a number that is all over the map. So there is no good answer for that. And even if you bound it to a single industry, how companies build out their applications, how they account for revenue, how they start structuring this, the numbers are still not going to converge because no two companies do this alike. But everyone is asking for a number, but there's no reasonable number to give. Until now, as an overconfident white man on stage, no one is going to question this. So it is 32 cents per monthly active user. That's your benchmark. That's the number you go for. And remember, I will not be taking questions on this. I will not be defending it. And every operations team in the world now immediately hates me for putting this up there because very few people are anywhere near this, but that's okay. They should just try harder. And of course, finance also comes at this from a very different perspective than an engineer does. They see giant Amazon bill, and their immediate question is, well, shouldn't we be seeing more boxes getting shipped here? And don't these people have full-time jobs? How are they possibly reading this much? There's a certain level of understanding that needs to bake into this. And again, engineering and finance talk past one another. And then you go to the other side of the world, engineering, a subject that folks at this conference are generally slightly more comfortable with. Well, except for me, that's a separate story. My code is garbage. And things that engineers care about are different, but they all generally tend to boil down to feature delivery. And this is fascinating because incentives tend to misalign. Very often, we'll talk to people who are engineers who have spent time working internally on reducing the AWS bill and then gotten yelled at review time for it. In one case, it was because they spent a month or so working on a bill that wasn't material. Okay, they were supposed to be working on something else. Fair. And in another case, someone spent 2 weeks doing it instead of taking on some features and blew $10 million off their bill. That seems like a net positive, but I don't have the context to weigh in on that. But mostly what engineers are incentivized on in every organization I talk to is about delivering features to market quickly. And it's the right answer for a business. There's a theoretical upside of how much you can cut your cloud bill of 100% of your cloud bill. You may have to go to Seattle and start taking hostages, but that's okay. We do what we have to do. We are excellent consultants. But when you get there, that's it. You can't get to a negative number there, but you can raise several times the amount of revenue that you're spending on cloud with the right feature to the right market at the right time. Being able to get there is valuable. Other things engineers tend to care about is a whole varying set of things that we can just sort of sum up as the computery parts. And if this slide doesn't resonate with you, I would suggest spending several hours trying to solve a bug that's a white space issue with the wrong kind of white space, but nothing is flagging it, and then tell me you're not swearing and flipping a table like an angry platypus. And what this gets to is that when we talk about governance, a word that everyone hates, and even now in the room I see people recoiling when I use it, but that's really what cost control is, you have to make it easier to do the right thing than the wrong thing, because shadow IT is a corporate credit card away. It has never been easier. So if you're building out processes as you migrate into a cloud type of world, and well, it used to take us 6 weeks to get a server provision, but now, thanks to the miracle of modern technology and cloud, we can get an instance spun up in 4 weeks. It's awful. Because if you have an approval process where a person has to approve these things, people are going to be at that person's desk every 20 minutes. Can I have a server? Can I have a server? Can I have a server? And when they finally get it, they do their thing. Are they turning it off? Of course not. It's hard to get people to turn things off even without ridiculous incentives like this, because people forget they want to move on, and cleaning up after ourselves is something some of us suck at. But if they have to go through that process to get it back, they're never going to give it up because it's painful to get that thing back up, and you just might need it again. Help move things more quickly. If guardrails make it harder to do your job, they're the wrong incentives, and no one's content. And of course, it's always worth mentioning, as some wit on Twitter said, the AWS bill is not a function of what you use in AWS, but rather a function of what you've forgotten to turn off. The bill never gets smaller, and this problem continues to grow. And at some point, something's going to snap, and I hope it's not me, but it might be. And the problem that we're seeing with all of this is that there's no API for business insight. If there were, you could suddenly have a software as a service tool that addresses all of these problems and more. But it is incredibly difficult to install an API into a human being without breaking the law. I've checked. Now, you can't be a real fake cloud economist without having a law or a rule named after yourself. And who in the world is, I guess, self-aggrandizing enough to do that for themselves? I am. Let's begin. This, for those who might be unaware, is a data center. When you build one of these, first, it takes longer than you think, it's harder than you think, and it is criminally expensive. But once it's built, and then you ask the question of, okay, what is the amortized cost of this thing for the next 3 years? You can come up with a really good answer, and it's highly accurate until the raccoons infest it and start carrying things off into the wilderness, but there's still some flex room in this. That's one end of a spectrum. The other, and this is not a joke, the serverless system I use to write my sarcastic newsletter every week. It's serverless. It costs me nothing except when I'm using it, and I can trace the flow of capital, to quote Simon Wardley, as it moves through here. Now, if I were instead, and I don't care about the money in this case because I use it a couple of times a week to build things out, and it adds up to a couple of cents. But if I were doing 10,000 newsletters a week, which first, no one wants me to do that, I promise. I'm nowhere near that funny. And that would be a lot of typing. But then as this continues to grow out, I can start identifying bottlenecks and which function in here is the most expensive part and look at optimizing it. And I could say that, OK, for every 1,000 newsletters, we start to see that we're going to cost X, Y, or Z. That, on the other hand, is not a lot of money, but it's also going to grow instead as a variable function based upon exactly how much traffic this thing gets. And I put these things on a spectrum. On the one side, you have data centers with the raccoon problems and all. And then we move into virtual machines or virtual instances. And you're getting cloudier. If you stop there, that's not really cloud native in the traditional sense, regardless of what VMware is choosing to sell this week. It solves the one specific problem, which is we suck at running data centers responsibly. So if that's true, great. That is a reason to start running something like VMware inside of another provider. But you're not done. It just winds up being more expensive on a dollar-for-dollar cost in some cases. Then you start dealing with things like auto-scaling. That is the official AWS artwork icon for an auto-scaling group because they do drawings about as well as they do service naming. I leave that on them, but roll with it. It's an auto-scaling group. And then we have things like Docker or Kubernetes. I hate using the word Kubernetes because I lose $5 every time I mention it on stage due to a terrible bet that I've made. And then you have serverless at the end of it, which I get $1 for every time I say it, because I also make good bets from time to time, but we'll see. And with serverless, you're not paying for anything that you're not using, but at this point, it winds up being extremely efficient, but also highly variable. The term cloudiness as well is probably not the real word, but NIST came up with 5 essential characteristics of cloud computing, as made popular by the Accelerate State of DevOps report, including Dr. Nicole Forsgren and some other folks whose names don't fit on a slide. And this was innovative and fascinating for a couple of reasons. One, it may be the first time in history that NIST has released something less than 400 pages, so people might actually read it. Secondly, because it distills it down, we have a definition around these things. And as a direct result of this, the Accelerate State of DevOps noticed that the cloudier something is, the likelier it was that the teams involved were higher performing. But we've noticed something else. As things wind up getting cloudier and cloudier, they become inherently more cost efficient. And that makes sense. If you have a bunch of instances or servers sitting in a data center that you have to buy for peak load, you can't sell them in the night when load is low again on eBay and then quickly buy them back before morning to put them back up. Not sensibly anyway. So it winds up being very cost inefficient. When you're just on the other end of the spectrum paying solely for what's used, then it's incredibly efficient. But there's an inverse here. Specifically, as something becomes cloudier and cloudier, it becomes increasingly difficult to predict in terms of absolute dollars and cents. So what works here when having these conversations with folks in finance is starting to articulate the value of this as a function of user count. If you want me to wind up putting it on a single slide suitable for tweeting, rage quoting, etc., there you have it. Because the more cost optimized an environment becomes, the harder it is to predict. This is the painful point. But the problem is that people are not hearing what finance is saying. They are asking, why is the bill so much more this month than last month? And what people hear incorrectly is, you're spending too much on the cloud, knock it off. That's not what finance is saying, but that's what people are hearing. Very often, it's help us understand what this is because we want to predict it. And saying that, well, it's going to continue to grow is not usually helpful. Being able to say things like, well, we have a fixed cost for things that are not particularly cloudy or serverless in that sense. Great. Then everything on top of that, for each additional 1,000 users, it'll cost us an additional Y. Then they stop bothering you and go talk to the business people about, well, when you say we're going to get this many users next year, how firm is that? And they're having a conversation that doesn't get misinterpreted as stop spending so much money. Otherwise, everyone's in a cost-cutting mode, and that tends to be relatively unpleasant. It's not fun. Finding ways to communicate with one another really makes everyone happy when you can have communication pathways that are productive and bidirectional. That's the point of having conversations with the business, and being able to have them in a reasonable way often helps. Now, I understand an awful lot of folks here are not themselves business people, and that's fine. And I mentioned there would be no APIs, so I'm going to call out a few things in AWS bills in the remaining 15 minutes here, and let me know if any of these resonate as we go through it. This requires no particular tooling other than a set of working eyes. You wouldn't think this would be worthy of including on a slide, but when you're looking at a bill and talking to customers about this, we started getting questions repeatedly about, so what's going on with this Alexa for Business charge? And it's $3 a month. Do you want $5? And we never talk. Why are you asking me this? Alphabetically, it's first in the bill. That's why. Start with the big numbers first. It's like, put out the big fire, we're working with a little fire next to it. It's just one of those good practices in life. And then you start looking at things that invariably crop up, like data transfer. Pop quiz time. Does anyone know how much it costs to move 1 terabyte of data in AWS? Too much? That is a valid answer, but that is subjective. The correct answer, though, is that no, you do not. No one does. Because the way that data transfer manifests in AWS is, frankly, ridiculous, and it's not at all clear. It's almost impossible to build a mental model of this that works. For example, finally, after reading contradictory documentation a couple weeks ago, we finally did an experiment with DD and Netcat. That's how terrible things are. When you have to break into the old school Unix toolbox in the cloud to figure out how things actually get built, there's a problem. But it turns out that sending data between availability zones in AWS costs just as much as sending that data between regions. Mostly. There are edge cases between them. Which means the cheapest single point to do replication between 2 EC2 instances is between Virginia and Ohio. For some reason, we're not entirely clear why, data transfer is half price between those 2 regions. My working theory is that even data wants to get the hell out of Ohio, but I'm not an Amazon planner, I couldn't tell you. And there are other things too. In some cases, it winds up being free to transfer data in and out of S3, for example, other than request charges. There's no data transfer inside of an AWS region. From the outside world, there is. Are you talking, you have 2 instances talking. They could wind up costing you nothing for data transfer or a lot of money, depending entirely on whether they're using public or private IP addresses to do it, despite the fact that they're in the same subnet. There's a lot of intricacy here, and I'm not suggesting people study this and figure out all the edge cases, but when you start seeing, data transfer is 1/3 of our bill, what's the story here? It's something to investigate deeper. This is available on the internet on our website. Feel free to snag it if you'd like, or tweet at me angrily until I respond with this image just to get people to stop bothering me. Follow-up question. Application load balancers. Does anyone know what those things cost? That's right, no one does. Let's talk about how it works, because this is not the old school elastic load balancer, which was you would have a per instance, per hour charge, and then a per gigabyte charge of things passing through it. That made an awful lot of sense. Then they looked at that and said, that's easily understandable. Are we going to let that stand? Not on our watch. We're coming up with the application load balancer, slightly less capable, slightly more scalable, and a stranger pricing model. I feel like I should preface this with the disclaimer that no, I am not making this up for laughs. You'd think I would by the end of this slide, but no, this is how it works. For starters, it's a per hour fee, which is the least complex part of all of it. Okay, if I have this, it's going to cost me some fixed fee per hour. Great. Then we go into Looney Tunes territory. 0.8 of a cent per LCU hour, or load balancer capacity unit. What the hell is an LCU, you might reasonably ask? Well, it's a few things. It contains 25 new connections per second, or 3,000 active connections per minute, or 1 gigabyte per hour of data transfer to instance targets, or S3, but not Lambda. Lambda, it's only 400 megabytes. and 1,000 rule evaluations per second. You look along those 4 dimensions, whichever the biggest one is how much it's going to cost you to run your load balancer. How straightforward. So the correct answer to how much does this cost is nobody knows. To get, finally, it feels almost under protest because they got tired of people egging their windows in Seattle, they added some CloudWatch metrics, which of course you pay for, on the elastic load balancers that used to exist before they were renamed Classic. Incidentally, that's how services get deprecated at AWS. When they don't want to maintain it anymore, they call it Classic, as opposed to Google, where they just go around the back and yank the power cord out. It's exciting and fun. But as you look at this, they now have those metrics that say what this would cost to convert this elastic load balancer to an ALB. That's great. What if you're coming from HA Proxy or Nginx or something else that isn't inherently cloud native? The way you find out is by testing it and seeing if the bill explodes. That's not really a great plan. It is a non-deterministic pricing model that no one knows how much it's going to cost them until after the fact. It's like going to the emergency room in the United States. So they use different math and different methodologies at AWS to figure out how things like load balancers, reserved instance pricing, data transfer, and whatnot cost. It's fun. It's exciting. It's kind of awful. Anyone seen Managed NAT Gateways? This is a service that came out a few years back. It's awesome except for the part where it's freaking horrible. For those who are not directly aware, you have things in private subnets and then things in public subnets. Public subnets can talk to the internet. Private subnets can't. So they need something that does NAT, standing in a public subnet that can talk into the private subnet and the outside world. You can run your own NAT instances, which is a bit of a pain, or you can use their managed NAT gateway for this. The problem is that this thing costs 4.5 cents per gigabyte passed through it, plus whatever data transfer winds up being incurred. So it's fine at small scale because you don't want to bother to run the pain of running these things. But then you talk to other folks and do a little diving and realize that 1/3 of their bill is data processing through a managed NAT gateway. It gets awful, and it doesn't ever stop. So it's one of those things that isn't a problem in most environments until suddenly it is. I also want to talk about data lifecycle policies and storage. Does anyone know what it costs to store a petabyte in AWS? This is not one of those nobody knows answers. This one actually has a real answer. The answer, of course, is that it depends. And these are actual prices, as I calculated out today. And there are options that are higher than this. You can get much more performant EBS volumes, and that can, in some cases, almost double that top number. And of course, you can wind up saving money by deleting all of the data and never speaking about it again. But how this winds up manifesting is fascinating and shines a little bit of a light on how cloud-native environments tend to think. The clouds more or less took a vote informally, and it seemed that object store won. If you're storing an amount of data on EBS or on disk in an AWS environment or storing it in S3, S3 is 23% of the cost of storing it on disk in most cases. And what's more is that once it's in S3, it has a durability guarantee. You can access it from any region, any availability zone in that region without data transfer fees. Whereas trying to have 2 or 3 copies of it inside on a disk means that first, you're paying 30 cents instead of 2.3 cents per gigabyte. Secondly, you're paying for that data to be transferred at, in most cases in that environment, it is 2 cents per gigabyte to transfer for each transition. It becomes extortionately expensive. But teaching your applications to suddenly talk to an object store isn't necessarily viable. It's also worth pointing out that object stores, in particular S3, are a lot smarter than they used to be. It's not just a place to dump data anymore. You can now have things like lifecycle transitions, where after a fixed period of time, we'll transition these objects out of the expensive tier into a less expensive tier, or even into Glacier, where it's going to cost way less, but at the bottom end with Deep Archive, it has a 12-hour retrieval window. So as long as you're aware of the constraints around this, it winds up becoming extremely efficient. You can also operate on all of those objects either by pattern or when certain events are met. You've separated compute from storage with this, but now that storage is learning to do compute operations on its own all over again. It's really interesting to watch. My name is Quinn. I am a cloud economist, and I will now take questions for the next 6 minutes or until dragged off the stage to your preference.
Thank you, Corey.
Of course.
And as a reminder, please use the microphone for any questions and keep your questions brief.
As people find their way to the microphone, it's always worth pointing out there are 3 things that are not questions. Calling bullshit on the entire premise of the talk, in my case, yeah, accurate, not a question. Comments aren't, and recite a spoken word version of your resume is also never a great question. You can condense all 3 of those into one bullshit, deeply compressed object with, that's not how we did it at Google. So feel free to throw that in as well. That's not just for this talk, I can handle it, but not everyone likes to have those conversations.
Hi, so you focused on AWS for the talk for the reasons you described.
Yes.
Have you found that Azure and GCP are equally insane with this kind of stuff? You know,
less so.
Zone pricing and stuff?
Yeah, great question. Less so, but more to the point, there was a sort of uncontested 5-year lead where AWS was the only game in town. So people started building on that. As a result, you have cloud environments that have a greater degree of maturity and in scale and in scope. So what we're seeing is that the dollar figures are simply larger. Our customers spend over $1 billion a year now on AWS. We aren't seeing a similar scale of problem in our market yet in the other providers. There's still complexity, and I understand why it is. You can't just say, it's not an all-you-can-eat buffet. All the computer you want for X dollars. That doesn't really work because there's always going to be edge cases. People want to only pay for the things that they use. But having all these additional dimensions hooked into it becomes a serious challenge. Now, Microsoft has some interesting advantages in that they already do deep deals with things like Office 365, GitHub, other things that tend to wind up being in Microsoft's orbit and existing long-term relationships with their customers. They can do interesting dances with licensing. They can move things around. Spend here could count toward this other thing. There's a lot more ability to move things around. AWS doesn't do that. Well, it turns out you buy a lot of books on Amazon, so it turns out that's never been a deal that we've seen.
Thank you.
Of course, great question. Other questions, concerns, comments, criticisms, thrown fruit, rotting or ripe, either way.
Hi.
Hi.
Okay, so I wonder, what do you think about the use of Kubernetes?
Using Kubernetes in what sense?
Basically, it can dense the computation into like big nodes,
yeah.
right?
The challenge with Kubernetes historically is that I almost a year ago now, I said that in 5 years, no one is going to care about Kubernetes. And I maintain that. I don't think it's going to go away, but I think it's going to become similar to systemd for the data center. Or a better example might be the Linux kernel, where you used to have to know an awful lot about these things, but these days, very few people do because it just works. I think container orchestration becomes the same thing. It absolutely improves the ability to get more usage out of finite resources instead of having them sit there idle. It is an approach that makes a lot of sense for some workloads. The problem that I have with Kubernetes is that it is layer upon layer of increasing complexity. It's not the getting it up problem that's the concern. It's that when suddenly we start seeing weird latency issues or outages and it's unclear why, it turns it into a murder mystery to some extent because no one is able to hold the complexity of the stack in their head, not well anyway. It's getting addressed in a variety of different ways, but right now it feels overcomplicated, I think is probably the best way to put it. And in every environment I've seen, the cost of infrastructure is far less than the compensation for people who have to maintain that infrastructure. Payroll is always a bigger expense than cloud spend. And there's a few very weird exceptions to that, I know. But by and large, every company is going to find that we're talking about in this room is likely to find themselves in that position. So trying to save money on infrastructure by massively overcomplicating the work that people have to do to maintain that is very often not economically sound. Great question, though. They are not accepting that talk yet at KubeCon, but I'm working on it.
One thing that we in our company we found was the bigger, or one of the more noticeable costs was in Redis. So run into a situation where addressing that is, I mean, do we just make better caching decisions, or is there a quick fix in your experience?
Redis, yeah. When you take a look at that being expensive, I'll follow up for you on that. Was that based on data transfer out to it? Was it the instances themselves that were running Redis? Okay. It depends entirely on the application architecture. In some cases, the Redis part is the most important part of the application, and that is the thing that needs to be up more than anything else. It really is going to vary on a case-by-case basis. It's challenging without having individual context into the environment itself to say, oh, that's terrible. You should not do it this way. I mean, if I wound up getting on stage and telling everyone they should do things a certain way, I'd probably be a much better fit for Google. But unfortunately, that's not really how it works. Context matters. So it's going to really come down to what the application's doing. Is it possible that it's over-spec'd as an easy fix? Sure, but I generally tend to assume that people have taken at least cursory looks at these things. It varies is the short answer. It would certainly be something that I've seen before in either direction. Great question, though.
And, okay.
One more, that's fine, we got it.
So once upon a time, we did like Unix 5 system accounting, and like Radius could keep track of things. And like when we designed protocols, the money that you spent was important in the designing of the very protocol.
Yes.
And then we as an industry kind of forgot about that. And this feels like we're remembering it again. How do you view that back and forth?
Great question. I really like that, it's philosophical. There are some folks who believe the answer to this is to go and have every engineer go through a 3-day training on how AWS billing works. I think that's the wrong move. I think that what an individual engineer needs to know, for the most part, fits on an index card. It's big things cost more than small things. If it's on, it's costing you money. And data transfer can vary. Talk to other folks. I think the idea for a cost-optimized team comprised of both finance folks and engineering in sort of an SRE-style model where they can be loaned out to various teams as they're going through the design and build phase is valuable. I think that the first question engineers try to solve is this thing possible? Can we build it? And let's build it. You can optimize after the fact, but no one is going to build a successful product or company by trying to do it for the least possible amount of money. Cost becomes a design concern, but I don't think it needs to be in the top 5 for everyone to have top of mind all the time. Great question. Thank you all for tolerating me. I appreciate it. I will be taking criticism in the lobby.